In a previous video, I showed you how to replace your background with an image. Now let's replace our foreground object with an image also. Just like last time, you'll need your image file already prepared. And if you don't know how to prepare one, that's in a separate video which you can watch. Here, I've got this nice image of a pie where I've already made the background transparent. So again, you can copy it, or do Control-C to copy, and then select the project here in IntelliJ and paste it. Okay, so you should see pie.png or whatever your file name is here. Just like last time, we actually have to load this file into a variable. So pimage is the data type for images. So I'm going to create another variable whose data type is pimage, but this one I'm going to call pie. You can name it whatever you want. You could call it Bob, you could call it ball. But pie is literally what the image is of, so I like to name my variables after what they contain. Then inside setup, just like last time, we will load the image using the load image command. And my image is called pie.png. Okay, so if we want to draw the image, you're going to use the image command. Here's where I'm currently drawing the ball. I'm actually going to leave that where it is. But I'm going to have the image command here where I draw the pie, and I'm going to draw it at x comma y, because x comma y is right now where I'm drawing the ellipse, and so those same coordinates are where I want to draw the image that I'm trying to replace the circle with. Okay, let's see what it looks like. So the size of the image is pretty good. You might notice, though, that it's not directly on top of the ball. It's sort of off to the side, and you might wonder why that is. Remember what the coordinate system looks like. We've got 0, 0 in the upper left-hand corner of the window. If I'm going to draw an ellipse at x comma y, that's what this statement does. What that means is it's going to draw the ellipse with the center of the ellipse at x comma y. And then 80 is the width, and 80 is the height. So that means this distance right here would be 40. Okay, what happens when we replace that with an image command? If I draw an image at xy, an image is always a rectangle. Even if you have a transparent background and the part that displays looks like a circle, like my pie, the image itself is always a rectangle. So the image command, the xy coordinates here, are going to draw your image with the xy coordinate being the upper left-hand corner of your image. So here is what my pie looks like. So that's why the pie is displaying a little bit right and a little bit down from where your circle used to be displaying. So one thing that you could do is, instead of telling your image to display at xy, you could tell the image that you want it to display a little bit shifted left and a little bit shifted up, so that way your circle in your image is going to appear to overlap where your old circle used to be. So how would you do that? First, you have to know what size your image is. I think that mine is 100 pixels by 100 pixels. So what I really want to do is I want to display it shifted left by exactly half of its width. So I'd want to shift it left by 50. So that means you can tell it to display the image not at x, but at x minus 50. And you don't want to display it at y, but at y minus 50. So in your display command, you can tell it to display shifted from where it actually is. So now, if this point in the middle of the ellipse is xy, x minus 50 is 50 pixels this way, y minus 50 is 50 pixels up, and that's where I could draw my image. And I said that the size of my image was 100 by 100, so it's going to display approximately here, and then my pie would display approximately there, more or less centered where the ellipse used to be centered. What's nice about this approach is your XY variables still describe the center of your image. So if you're doing collision detection, or if you're doing bouncing, where you're saying like reverse direction when the right-hand side of your object hits the wall, the right-hand side of your object is still x plus whatever half the width is. So the only thing you might have to change would be something like this. So before you might have had an if statement that's something like this. When you had an ellipse that's width was 80, you'd say if the x-coordinate, which is the center of the ellipse, plus 40, which is the radius, so that's like the right-hand side of the ellipse. So if the right-hand side of the ellipse is bigger than 800, then reverse the x speed. Now, x still describes the center of your image, but your image is a different size than your ellipse was, maybe. So again, you have to know what size your image is. And for me, because my image is 100, and I've displayed it shifted by 50 over, that means kind of the radius, if you will, that half the width is actually 50. So to get from the center to the right-hand side of my image, I don't add 40 from my ellipse statement. I have to add 50 because that's half the width of my image. So you'll maybe have to make changes like that if you want really kind of pixel perfect collision detection or bouncing. Another thing to note is you only have to do that kind of stuff if you're replacing a circle with an image. If you're replacing a rectangle with an image, no changes are necessary because a rectangle already uses x and y to describe the upper left-hand corner. So when you draw an image there, there's no change. XY still describes the upper left-hand corner. So let's do it in code. In my code here, I've shifted the image. Let's see what that looks like when I display it. So you can see now the pi is more or less centered where my circle used to be. So let's go ahead and now remove the code that displays the ellipse, and we'll have the pi alone. And that's pretty good. In fact, it's so good that I can't actually tell that the bouncing is slightly wrong. But if you wanted to, you could also adjust, like I said, the bouncing coordinates there. Okay, I hope that this was helpful.